Now let us discuss a new concept, that is Pascal's law. Okay. So from fluid mechanics only. Okay. Uh, if you want to know that concept, you can connect me to the WhatsApp. So what is Pascal's law in it? Okay. Say I am having a uh, container, but completely filled with liquid or a particular fluid. Okay, incompressible fluid. Say this is a container, okay, any shape I can say. And it is completely filled, okay. Remember, there should not be any empty space. If there is some empty space, now you can say that, say air is there, okay. So you can say that it will be a mixture of two liquid, okay, two fluid. One is say liquid, another is gas, okay, like that. So that Pascal's law will not be valid, okay, there. So Pascal's law will be valid only when there is a single fluid, okay? And second thing, the fluid should be incompressible, non-viscous, okay? These are some that one criteria of Pascal's law, okay? That must be like that. So liquid must be incompressible, completely filled. Why it is completely filled? If it is not completely filled, actually there will be two fluids, okay, like that. One is a liquid, another is a gas, okay, like that. And also non-viscous, okay. Non-viscous is just for friction only, okay. Anyway, so what is Pascal's law? Let us understand first, huh? Say, I understand that the pressure at this point will not be equal to the pressure at this point, okay? Because you see, there may be some height difference, okay? So pressure may be different, okay? But you see, say I have that one. Put a piston here, okay? I have put a piston here. So this is the piston, okay? So then I have placed one more piston at some other point too, okay? Say I have pressed the piston, okay? With a force F1, and say area of the that one piston is say A1, okay? So if I press it, so obviously the pressure will increase at this point, okay? Or if I pull the piston, then obviously the pressure at this point will decrease, okay? Change, okay? So what Pascal's law say that increment or decrement of the pressure will be transmitted at every point equally and undiminished, okay? Say earlier, at this point, say pressure is 50, okay? And at this point, say pressure is 60. But when I press it, so pressure here say increased by 5, then here also it will be increased by 5 only, okay? If I press it more, say it is increased by 2, then here also it will be, okay? And if I take some another point, say this is point number C, say it was earlier, it was having pressure 70. You remember, pressure is not same, you see, 50, 60, 70 like that. But if I press it, the pressure will be increased by 5 only, okay? If I increase by 5, then here also 5 will be increased. If I increase by 2, okay, then every year it will be increased. It means increment or decrement of pressure is transmitted everywhere undiminished, okay, in a incompressible, non-viscous liquid completely filled in a container, okay. So if I, that one, say if I put one another piston here, okay, say little more area, okay, more area. Say this is the piston, okay. So I'll get a force F2 because if I press it, so here also at this point also pressure will be developed. Okay. So it means that increment or decrement of the pressure will be same. Okay. So let us write this. Okay. What is Pascal's law? In a incompressible non-viscous, viscous means sticky nature of liquid. Okay. Non-viscous means it is not sticky. Okay. What I am doing. In a incompressible non-viscous liquid, completely filled in a closed container, the pressure difference created at any point inside transmits equally undiminished in all directions in the liquid. Okay. Actually, you see, I don't say that this Pascal's law will be valid in case of gas also. Okay. Actually, gas is easily compressible. Na? That is why we use the Pascal's law in case of liquid only. Okay. It should, ideally, it should hold for that all fluids. But actually, you know that gas and liquid altogether we call fluid. But gas is easily compressible. Okay. So that it will be valid only when it is incompressible. So that is why Pascal's law valid only in that only. Okay. Liquid. Anyway, so you see one more situation I can that one show you. It has lot of applications. Okay, like hydraulic brake. Okay, that hydraulic jack. Okay, then you can say hydraulic lift. Okay, lot of. So I'm going to give you a little bit one example. Okay. So at this point, say pressure at this point, okay, that pressure is nothing but pressure increment, okay. You can say that del P1 also, okay, must be equal to del P2, okay, according to this. So pressure is equal to extra pressure, I got it. It is nothing but F1 by A1 only. And extra pressure I got it is nothing but F2 by A2, okay. So from here you can see F2 equal to A2 by A1 into F1, okay. So that is a very important formula. See, F1 is, say, I am giving this force, okay? Say it is a hydraulic brake, okay? The brake of your car. So if you press this brake by your feet, okay? Then what will happen? You are pressing with some small amount of force only, na? But I can generate a huge amount of force, 1,000 times, 10,000 times, okay? Force using this technique. How you see? I have applied F force, F1 force. If A2 is means area of the second piston is very, very greater than A1. So means say this is one that one millimeter square area and this is say that one 10 centimeter square area. Okay. So area is very high. Okay. So obviously the force also will be high. Okay. Then F2 also will be very, very high. Then so it can be, the technique can be used as a force multiplier. Okay. Means we can generate large number of force, a large amount of force, okay, using this technique actually. So using the principle of Pascal's law, we can generate large amount of force. Okay. But remember, work done by me on the first piston and the work done received in the second piston, both are same. Force is large, okay, but work done is same. Otherwise, you see, it will be a violation of energy, okay. So work done in the first piston and the work done in the second piston, both are actually same, okay. It is not that we have produced some energy, okay. It is not like that. Even I can prove it also, you see. Say I am taking two the small piston, okay? Then I have given some large area, okay? Like this, okay? Say this one is the piston. Well, say this is the second piston, okay? And say this is the first piston. So inside it, okay, we have say liquid. Okay? We have say liquid. But remember it is incompressible, okay? So if I press the first piston, okay? If I press the first piston, okay? So due to the pressing, say first piston goes to this position, okay? It means A1 goes by X1, okay? So that way A2 will be going by some X2, okay? Up to X2 position it will go. So this much. But remember, as the mass is conserved, as the density is same, so volume also must be same only, na? So this volume, if it is V1, this volume, if it is V2, so volume must be same. Okay. So volume 1 must be equal to volume 2. So it means volume is nothing but area 1 x1 must be equal to area 2 x2. Okay. Because area into displacement is nothing but the volume only. No? So what the work I received in that one, okay, second piston, okay. So what the work I have received in the second piston, if it is W2, say I have received the work W2. Okay, W2 is nothing but F2 into X2. But I know that F2 is nothing but A2 by A1 into F1. Okay, from this expression. And X2 is nothing but from this expression, from conservation of volume, you can say. Okay, so X2 is nothing but A1 by A2, A1 by A2 into X1 only. So now you can see A2 will get cancelled, A1 will get cancelled. So it is nothing but F1 into X1 only. So force into displacement, F1 into X1 is nothing but work done in the first piston. So work done in the second piston is equal to work done in the first piston. It means no one is doing extra work, okay? So just work done by me is converted, okay, to the work done on the other piston only, okay? And you can also find this same thing only, na? When you press a hydraulic brake, okay, you can also feel na, in your car, okay, or in even your scooter also like that, bike also. If you press it, say you press by 5 or 10 centimeters like that, na, you press it, na? But you can see on the wheel, the brake, okay, it is actually just less than a millimeter away, na, that brake. If you find it, na, you can see also, okay. So it means displacement is where force is more, displacement is less, and where force is less, displacement is more. Okay, so work done is remaining same. Okay,